Hi students. In the last lecture, I have discussed Biot-Savart law, and using that, I have discussed how to calculate a field due to finite straight wire carrying current. Okay, let us now continue. Next one, field at the center of a circular wire carrying current. Right? See how to calculate. So we are taking a circular wire carrying current. It is a circular wire carrying current. Suppose current is anti-clockwise. Let us take current is anti-clockwise. Its value is I. And take radius is R. So we want to calculate now strength of the magnetic field at its center. Okay. Now see what we are doing. So first focus from Biot-Savart's law. dB bar is equal to mu naught by 4 pi I into dl bar cross r bar upon r cube. Okay. So now we are going to apply this one to calculate a field at the center of the circular wire, which is carrying current. So now what I'm doing here, let us consider one small element on this wire. I am taking a small part. Its length is now dl. Okay. And direction of dl bar is direction of current. Current is now like this. Okay. That means now what happens? Coming to r bar, it is a position vector of the point where we want to calculate a field with respect to the current element. That means this is now r bar. Okay. Position vector of this point where we want to calculate strength of the field with respect to current element. And you can see here between this dl bar and r bar angle is 90. Okay. So it is dl into r into sin 90 and one r gets cancelled. Right. That means it becomes now mu naught upon 4 pi I dl. Here r is there and r cubed. It becomes r square sin 90. Okay. Between dl bar and r bar angle is 90. So sin 90. Right. Like this, we have to consider all elements. Okay. And we have to calculate strength of the field. That means now we have to take sum of all these things. Sum of all these things. So B equal to. So focus now carefully. Direction of dl bar cross r. dl bar cross r bar. Let us consider it is an xy plane. This is x and this is y. According to this, you can see dl bar. Its direction is now j cap. And r bar, it is minus I cap. Then see what we get. J cap cross minus I cap. J cap cross minus I cap. Then see what we get. We are knowing that I cap cross J cap is K cap. It is now reverse. So minus K cap. And here minus is there. So it is now K cap. Okay. That means at the center of the circular wire, direction of field is now outwards, means towards us and normal to this board plane. Okay. Or same thing we can say like this. So take your right hand, curl fingers along the current flow. I am repeating. Take right hand, curl fingers along the current flow. So curl fingers now anti-clockwise. See, thumb will be towards us. That means it is along positive z axis. Okay. Either we can say in that way or by using for element like this. Okay. DL bar cross R bar. Now integrate. You can see mu naught by 4 pi constant. I is a constant. R square is a constant. Remaining is now, of course, sine 90 it is 1. Remaining is only DL. That means it is a mu naught upon 4 pi I by R square sine 90 is 1. Integration of DL. If you take now sum of these lengths DL, and again I'm taking DL, again taking DL, sum of all these things, that gives us circumference, right? That is now mu naught I upon 4 pi R square into 2 pi R. Okay. Or if you are taking it is now radius is capital R. Not given right? Radius is capital R. Then say what we get pi gets cancelled. This is now here 2 times mu naught I by and 1 R gets cancelled. Mu naught I by 2 R. Then R is now radius of the circle. Suppose we have now n turns. We are having now n turns. So for single turn, this is a field. If we have n turns, it is into n. Okay. That is now strength of the field at the center of a current carrying wire. It is subtler wire, right? Now, suppose we have only some part of a wire, means subtler arc. Suppose I am taking here subtler arc. So taking here an arc, okay, and this arc subtends an angle theta at its center of curvature. This is theta, okay. Next, suppose the current is now like this. Now see what happens. Coming to here, I am writing the same thing as at the center B value mu naught Ni. Here N stands for number of turns. Okay. So mu naught Ni by 2R. Now multiplying with the theta and divide with the 2 pi. See carefully. Suppose if you are taking now complete one, then theta equal to 2 pi. Then 2 pi. 2 pi by 2 pi, that is 1. If you are taking half circle, then theta will be pi. Then pi by 2 pi. It becomes mu naught Ni by 4R. So like this, if we are given circular arc, then field strength at the center of curvature is given by mu naught Ni by 2R into theta by 2 pi. Okay. And direction. Either you can take DL bar cross R bar, otherwise curl fingers of right hand along the current flow. Then thumb indicates direction of field, right? Let us see next one. In this next one, the third one, field at a point on the axis of a circular wire. So now we have discussed at the center. Now it is on the on the axis. Let us see. Right, let us consider a circular wire which is carrying current. We want to calculate strength of the field or its axis at some distance x. This is x. Okay. Now see what we are doing here. Let us issue. Current is now. Suppose the current is like this. Current is I. Now see here what I am doing is. Suppose take reduces are right. Now I am taking one element. Let us say at the topmost point. So one element of length dl. Okay. So we can see now if this board plane is xy plane, board plane is xy plane. Now this ring is now in yz plane. I am repeating. I have taken this board as xy plane. Ring is now in yz plane. Okay. That means this current will be when current is like this. If I am taking the topmost point, then this current will be towards us. Okay. This current will be towards us. Now, because of this element, at this point, see what is a field. So I'm showing now this point means that current element with this point where we want to calculate now field strength. Okay. This is now DL bar. DL bar is now towards us, right? That means it is now K cap, right? And you can see R bar. R bar is now you can see this is R bar. Okay. That is now R bar. Means we have taken position vector of the point where we want to calculate the strength of the field with respect to the current element. And you can see this R bar is normal to this DL bar, right? So I'm taking here Biot-Savart's law. So dB bar is equal to mu naught by 4 pi I into DL bar cross R bar upon R cube, right? So here this is now DL bar. Direction is now K cap, okay? And this is now R bar, right? So because of this element at this location, direction of field. So now you should be very careful. See what I'm saying is, we have learned that when we are taking cross product, that result will be normal to the plane containing both the vectors, right? So now what I'm saying is that consider a plane which contains this DL bar and R bar. Okay. So now take your right hand, keep the thumb along the current flow. Here current is now towards us. Okay. So keep the thumb of right hand towards us, curl fingers. Okay. Then the curling fingers will be normal to this plane and direction will be, it will be like normal to this plane. This is now direction of B bar. This is now DB bar. See what we are doing here. So we are keeping thumb of right hand along this DL bar. So in this problem, DL bar is now along Z axis. So keep thumb towards us, curl fingers. Okay. Now this is a plane. This is a plane. So normal to this plane. So normal to this plane means when we are curling fingers, they will be coming now like this. This is now DB bar. Okay. So now I am taking diametrically opposite one more element. So let us take diametrically opposite one more element. So this is now DL bar. And for this one, DL bar direction is into the board, means minus K cap. Now, with respect to this element, for this point, position vector will be So position vector will be, you can see now here, join this element to this point. This is now R bar. Again, now take this plane, okay? So take your right hand, keep the thumb inwards, means normal to the board inwards, curl fingers, okay? Then normal to this plane, normal to this plane will be, it will be like this. This is normal to this plane, dB bar, okay? Let us take this R bar vector makes angle theta with this axis. This is a theta. Then this also theta, right? Now see what happens. For this one component normal to axis and for this component normal to axis, these two will cancel. So remaining is now only component along the axis. That means here resultant is now along the axis. Okay. Now see that value how much? So B equal to integration of, see here what we get, the parallel component. This is a theta. If I extend this line, okay, that makes how much angle? It is now normally is dB cos theta, and this is now dB sin theta. So integration of dB sin theta. So in the place of dB, see what we have, right? Mu naught by 4 pi I dl only, dl only. This is R and this is R cube. Remaining is R square. Okay. Here see what is now distance. This distance how much? This is X and this is now capital R. So distance will be R square plus X square under root. And we want here R square. That's why R square plus X square. Okay. Next. Between DL bar and R bar, angle is 90. So it is sin 90. Right. Next, into sin theta. Right. Into sin theta means see what we get. Sin theta equal to opposite by hypotenuse. Opposite is now R. Hypotenuse is now this length, which is equal to root of R square plus X square. So it becomes now power 3 by 2. Already having it is power 1. Now writing here root of R square plus X square. It becomes now power 3 by 2. Now in this we can take constants outside. So mu naught by 4 pi. It is I R. This is R square plus X square whole power 3 by 2. Integration of dl. That gives 2 pi r, right? So it is now into 2 pi r, right? Now see what is the value. See calculation part. So this is for one turn. Okay, if you are having n turns, if we have n turns, this becomes now into n. Okay. So for n turns, so B will be, see first of all calculation here. Pi and pi gets cancelled. So it is now pi gets cancelled. And 2 here 2 times r and r square, right? So it is now mu naught n I r square upon 2 into r square plus x square whole power 3 by 2, right? And you can see direction of this field. Direction of this field is along the axis of the ring. Okay. Or you can do one thing. In this, you can see its a component is now like this means along x-axis, right? Along x-axis. Or what I'm saying is, take your right hand, curl fingers along this current. Okay. Then our thumb will be towards our right side. That means it is along x-axis. So it is along the axis, right? This is a value. Now see here what we are doing. Suppose if x is very large compared to r, if x is very large compared to r, then see what we get. B equal to x very large means r square plus x square. It becomes only x square power 3 by 2. It becomes now 2x cube, right? So mu naught by 4 pi, mu naught by 4 pi. It is nir square, nir square upon, wait, there is no 4 pi, right? There is no 4 pi here. It is only mu naught nir square by mu naught nir square by 2x cube, right? That's enough. Okay. Now here what I'm doing is writing the same thing as multiply and divide with the 2 pi. Okay. Multiply and divide with the 2 pi. Then this becomes now mu naught by 4 pi. So we're taking it 2 pi. So it is now 2 into n into pi r square into y. Okay. Upon x cube. Okay. So this is now mu naught by 4 pi 2 m bar upon x cube. Okay. Where m bar is equal to I n a bar, because here pi r square is now area of the circle. Okay. And if you curl fingers, means we have learned in mathematics, area of a plane is normal to that plane, right? So here what we are doing is we are taking now direction of current. So curl fingers of right hand along the current flow. Then the thumb will be along positive x-axis. So taking that as direction of a bar. Okay. So m bar equal to I into n into a bar. And this m bar is known as magnetic dipole moment. So earlier we have learned that current carrying loop acts as a magnet. Okay. So this is the magnetic dipole moment. Or if you remember, while discussing electric dipole moment, so in that we have seen K into, I'm writing here, in case of electric dipole, on its axis, what is a field? Electric field equal to K into 2p by r cube, or distance is x, 2p by x cube, or E bar equal to 2p bar. Now only change in the place of K, it is now mu naught by 4 pi. In the place of P bar, it is now M bar. So P bar, electric dipole moment, and M bar, it is a magnetic dipole moment. And you can see here, direction of M bar, it is from south to north. Okay. If you see carefully here, if we look at this ring from this side, okay, how current appears to be? Current appears to be anti-clockwise, right? Means this face acts as north pole. The face behind this one acts as south pole. So direction is now from south to north. That is now in this diagram along positive x-axis, right?